Good afternoon, class. My name is Adam Hendriksen, and I'm going to be discussing some of the anatomy and landmarks of the sheep's brain required to dissect. Before I continue, I'm going to show you my workspace just to show you that there's no additional reference material other than the documents of the structure of the brain. I got my dissection kit. I used a marker to dot a few portions of the specimen just to kind of help highlight where I think the region would be. Again, the anatomy of a sheep's brain is obviously a little bit different than a human's, specifically the spinal cord going posterior instead of inferior. So first we're just going to discuss the landmarks described, and we'll go from there. The cerebrum is this outer portion here, and is about 85% of the brain's mass there. It's broken into two hemispheres, and as you can see, these mounds here are your gyrus regions, and your sulcuses are these deep kind of cavities here on the side, that deep grooves into the sides of the brain itself. The longitudinal cerebral fissure is actually that center line there, where we actually used as a landmark to separate the two hemispheres. Then we go into the brain stem, starting with the midbrain, which appears to be this portion here, kind of marked up front. Then we move down to our pons and then to our medulla oblongata. So we got our midbrain here, and then this appears to be the pons, which would be displaced if the spinal cord was coming straight down, and then our medulla oblongata below that. The cerebral peduncle would actually be the midbrain mass itself, and then the superior and inferior colliculuses would be these four nodules that would push out of the front. And this obviously superior being higher than inferior. The cerebellum is pretty easily distinguished here, and as you can see, you still have all these the white and gray matter there. That's very obvious. The vermis would be the section connecting the two hemispheres of the cerebellum, and then that creates your lateral hemispheres, both left and right. The meninges or dura mater I thought would be a little more prominent if we actually removed the brain from the skull itself, but I did find a decent example where I could separate the dura mater being the top layer, the arachnoid layer being this middle section here, which is a little more like the spinal tissue itself, and then the pia mater below that. And below here we have our pituitary, or what I think is the pituitary gland, right here. Let's see, and then the cranial nerves, which are best displayed from the inferior portion of the brain itself. As you can see, the olfactory bulb and nerve are very, very obvious, which kind of tells you a little bit of something about this creature, that it uses this sense quite frequently and it relies on it. It's very important to it. The optic nerve is a little harder to see, and it appears to be this portion here, these two black lines next to cranial nerve 1. Cranial nerve 3 and the oculomotor portions are even further in, and those control the motion of the eyes itself. The trochlear is not visible at this time. The trigeminal kind of comes over what I think is the pons section here. Very well displayed. And the abducens are not visible at this time. Then we go to our mid-sagittal section, mid-sagittal planes, to try and look for some of these inner landmarks. Corpus callosum appears to be the hat of this brain, this white matter here, this kind of cap that goes over it. And that houses our thalamus and then hypothalamus below that. The ventricles here are these divots here that hold the cerebral spinal fluid. The other portion here actually shows a lot more. Here you have a ventricle, and another ventricle there. So we have the lateral ventricles on the sides there, and then the third and fourth ventricle moving downward from the spine. The cerebral aqueduct would be a central tube that kind of passes through. When I cut off a portion of the spinal cord, it became a little more apparent where that aqueduct would sit, okay? And kind of The glove's getting in the way here. I don't want to drop it. Okay, the center section here, lowered. Hold on. When you pinch it together, you can see where that aqueduct actually lies. It's not as prominent because, again, we cut it down the center, so I may have gotten that aqueduct cut in half pretty well. The arbor vitae is actually the white matter of the cerebellum. And although the spinal cord, I thought it would be more prominent, the color changes from gray to white when you transect it. Again, okay, hold on a second. See if I can piece this back together. As you can see, the butterfly region of it isn't quite as obvious when you get it back together, but you can see it there. And it's more of a textural change than anything else. Gray matter would be on the inside of the spinal cord, white matter would be on the outside. The dorsal nerves were not apparent, but that would be on the posterior portion of the back portion, much like the dorsal fin of a dolphin, so it would be the back portion of the spinal cord, and then the ventral roots would be the anterior chest portion of those roots. So I hope you found this educational and helpful, and thank you for your time.